In this video, we're going to be talking about the product rule, which is something we use whenever we want to take the derivative of two functions being multiplied. The formal definition of the product rule states the following. This means that the derivative is going to be one function times the derivative of the other function plus vice versa. Let's get a better understanding of that with a couple examples. So for our first example, let's take the derivative of 5x squared times 6x cubed. These are two functions being multiplied together. Let's choose 5x squared to be f and 6x cubed to be g. In this case, what we are going to do is apply our formal definition. So it's going to be one function times the derivative of the other function. So here we're going to do g prime of x. So this is g, right? And we have to take the derivative of this. So let's just keep 6 where it is because it's a constant. And now let's use the power rule, which is going to be 6 times 3x squared. And remember, a very important part about the product rule is that we are adding here. Addition is the operation, not anything else. And here, what we're going to do is now we're going to do the opposite process. So here we started with f. Now we're going to start with f prime. So the derivative of 5x squared is going to be 5 times 2x. This was another implementation of the power rule. And now, since we just calculated g prime of x over here, we're just going to write g of x. And we're going to directly copy down 6x cubed. Now all we're going to do is we're just going to simplify that answer. In our second example, let's try something a little more challenging, where we are going to be taking the derivative of something that has more than one term in each function. All right, so here we're having two terms in f and two terms in g. Let's think back to our f times g prime plus f prime times g framework. And it's still the same process. So first, we're going to just directly copy down f. And now we're going to take the derivative of g, okay? And that is going to be -3. We'll leave that constant b. We'll implement the power rule, so that's times 2x. And the derivative of any constant is 0, so we just leave that out. Now we're going to add our plus sign. And next, we are going to take the derivative of f. So that is going to be 6 times an implementation of the power rule, 5x to the power of 4. And then we are going to just copy down g as is. And now what I'll do is I will combine. Now, in our previous example, we stopped at about here, which in some cases is actually okay. But what we can do is we can actually simplify further from this, and we can get our final answer to be a polynomial. And I just wanted to show how that would be on this example if that were required, if we needed something as a polynomial. So, how do we go about that? Well, let's take this and let's distribute it to these two terms over here. That would give us -36 x to the power of 6 minus 24 x. And here you can see where I got that from. And now let's do some more of that. So let's take this 30x to the 4 and let's distribute that. Okay, and then for our final step, we are just going to combine like terms. 126x to the power of 6. I got this by just combining these terms that had the same powers, and then we will just copy down the rest of them. And now this is going to be our final answer for the derivative that we took in example 2, and I brought it to polynomial form. Thank you for watching and good luck studying!